Hello, I am the MightyPEZ. In this video, I will show you how to troubleshoot two common issues with the SeeSii FG-100 signal generator. I will then briefly demonstrate the operations of the device. So please join me. Hello. So I had not intended on doing an unboxing, teardown, or review video. My intent was actually just to show a low-frequency sine wave clock signal in another project that I was working on. So for that purpose, I purchased this cheap Chinese function generator for under $30, with the only requirement that it could generate a passable low-frequency sine and triangle wave. However, the device came in DOA, so I thought I would make a video out of it. Full disclosure, I've already opened the device to resolve a well-known issue number one, that the display would not light up. So this is a normal complaint, and for reasons I will show you. However, I broke a cardinal rule of tinkering. I buttoned the whole case back up before testing to see if it actually worked. So, boys and girls, pop quiz, what do we do when something is broken? That's right, we take it apart. So I'm going to take this device apart, and we'll see if we can figure out why the device is dead. So as promised, I will show you the first issue. Many of these devices do show up DOA. The display won't even light up, and that's because it is only attached with a single screw. Even though there's 4 screw positions, many of these devices are reported only showing up as this one did, with a single post. In fact, that single post was loose at the time, and the entire display was not seated. So we'll go remove the display. This is what I'd already fixed previously. Prior to that, the screen wouldn't even light up, but it is still dead. So we're going to look at this a little more, see what we have here. So thanks to a simple return policy, 2 days later, I now have a second device, and hopefully this one will work. We're going to plug it in. Sure enough, it powers up, and the display not only lights up, but displays the expected menu out of the box. So I'll go ahead and take the case apart on this working unit so that I can compare the two and see if we can tell what is not allowing the display on the non-functional device to render text. Okay, now we can see that we have our second working unit with the case off. I'm going to go ahead and remove the display. See if there's anything that stands out as being different. So additionally, I will note that while I had the case open, I did notice that that one standoff was also loose, and I tightened that down. Again, when we reattach the display in both devices, we want to make sure that they are tight and will not loosen up and pull back away from the header. Okay, well, I had both of these units taken apart. I went ahead and tested with my multimeter to make sure that the signal level on all of the output pins for the LCD matched up, and they did. So they are getting the correct signal levels. But I did notice, having the LCD off, that there's a adjustable resistor, variable resistor on each of these devices. So it got me thinking that possibly our issue is as simple as a mismatch in the resistor setting, not allowing enough brightness for the letters. So possibly the device is working, but the LCD display is actually not getting enough power to generate the letters. So we're going to go ahead and put these LCDs back on. Make sure they're seated properly. So I have the new device on top and the old device on bottom. I'm going to apply power to each one. We can see that, sure enough, the menu shows up on the first one and I can see it. But on the second one, it's getting backlight power, but it is not getting enough signal to the font. So that's my theory. And we're going to really quickly prove this out by adjusting with a screwdriver. Sure enough, you can see I've already, just with a slight adjustment, I'm able to get a good solid display. So that's all this was. Initially, this device came in with an LCD display that was unseated. I reseated it, but still the resistor, variable resistor setting was not correct. So this turned out to be a much easier fix than I had originally thought. I was all ready to chalk it up as being a failed device. Turns out that it works the same as the one that was sent as a replacement. So I'm going to wind up buttoning this back up and sending it back and keeping the replacement device. Now that we have both devices operating correctly, I'll go ahead and demonstrate the functionality of the SeeSii FG-100 signal generator. There are two types of controls on the signal generator. There are the control buttons for setting up the waveform, and these must be selected while the generator is stopped. Here you can see the mode button. This will cycle through the different types of waveforms that you can select. Then we have the cursor button, which selects the digit of the frequency that we want to adjust. So here we're going to take the 100,000 kilohertz and set it to 0. And then we're going to take the cursor all the way down to the 1's position and set it to 1 hertz. Then we're going to hit the run stop button, which will enable the waveform. And there we're generating a signal. Now, as mentioned, there are also controls that you can adjust while the waveform is running. We have an amplitude adjustment. Here I'm reducing the amplitude, and I'll raise it up. Then we have a DC offset adjustment, which will shift up or down the waveform. Here I'm reducing it until we can see clipping on the lower end at about 12.5 volts. And increase the offset until we see clipping on the top end, again about 12 volts. Now we'll center the adjustment again. And reduce the amplitude till we get an amplitude of 0, which will allow us to adjust up till we're centered on 0. Now I'll raise the amplitude back up. We're currently showing 5 volt per division, so I'm going to set the waveform to run from about +5 to -5 volts. And then we're going to cycle through the different types of waveforms. So we'll go ahead and stop the signal generator using the mode button. We're going to test a square wave. Again, we'll enable the signal generator. And you can see we have a passable 1 hertz square wave. Again, stopping the signal generator. We'll switch to a triangle wave. Stopping again, sawtooth, and we'll do a reverse sawtooth. So at low frequency, all these waves are very passable. Now we'll go ahead and raise the frequency up using the cursor. We'll go to the 100 Hertz range, increase that to 1, move the cursor to the ones, and reduce that to 0. So now we're set for 100 Hertz. We'll go ahead and increase the sample rate. Of the oscilloscope. There we go. So again, at 100 Hertz, we also have a passable wave. Go ahead and cycle through a couple of the waveforms. Square wave, a little bit of noise, not too bad at 100 Hertz. Triangle wave, pretty clean. Sawtooth. We'll skip the reverse sawtooth, go back to the sine wave, and then we're going to raise the frequency from 100 Hertz to 1 kilohertz. Again, we'll change the oscilloscope to a higher sampling rate. So the sine wave at 1 kilohertz looks pretty normal. Let's look at the square wave. We can see a little bit of noise. In fact, on both the rising and falling edge, there appears to be a little bit of a hiccup that could possibly cause bouncing on a trigger. Triangle wave, normal. Sawtooth, a little bit of noise on the sawtooth on the falling edge. And a little bit of noise on the rising edge of the reverse sawtooth. So 1 kilohertz looks pretty normal, but we are starting to see noise. So let's go ahead and stop the signal generator again. We're going to increase the frequency to 5 kilohertz and see what we get. We can start seeing more noise in the sine wave. Let's go ahead and increase the sample rate on the oscilloscope. Not too much noise. We can change the amplitude and see if that affects the noise. It just shifts the noise around, doesn't really increase or decrease the noise. So let's go ahead and stop it again. We're going to change this to 10 kilohertz. And now we can see a lot of noise in the sine wave. That is a pretty ugly sine wave. Let's look at some of the other waveforms. Yeah, it definitely does not look like a square wave. Right now it looks like at 10 kilohertz our sine and our square waves seem quite similar. Let's lower the amplitude. Go back to the square wave. Okay. So at a lower amplitude we see more of a distinct cutoff. Not quite sure I'd refer to that as a square wave. It's definitely pretty noisy and nowhere near the theoretical 500 kilohertz. So we're going to go from 10 kilohertz to 100 kilohertz. And at 100 kilohertz, we have lost a lot of our amplitude. Looks like we are only able to go between about 1 and negative 1.5 volts. So we're down to 2.5 volts peak to peak. So at 100 kilohertz, we've pretty much become useless. So, summary. First, the pluses. The price is under $30, which, if it provides any value to you, may be worth it. The device provides a passable low-frequency signal at various waveforms. Unfortunately, the negatives, the signal starts to break down between 100 Hz and 1 kHz, depending on waveform selected. Nowhere near the theoretical max of 500 kHz. There is no fine grain adjustment, which is good as long as close enough is good for you. Is it worth it? For me it is. And I found that it provides an acceptable slow clock for my test circuits, but just be aware of the shortcomings. As an aside, I have read reviews that confirm my observations. However, I've also seen evidence that over the years there have been devices that may have been built with better components and provided stability at a higher frequency. There are posts regarding some users who have swapped out various components to get better accuracy. However, I'm not willing to lose my $30 investment to try and remove and resolder any surface mount components. And with that, I will wrap up this video with a closing thought. As stated, I had no intention of doing an unboxing video, and therefore I feel I must finish this video by showing what comes with the package. Besides the signal generator, the USB to power adapter is also provided. Please note that there is no provided BNC to probe provided, and you must purchase that item separately. For my use case, this BNC to micrograbber cable works perfectly to provide a clock signal to my breadboard projects. And with that, I thank you for watching this video, and happy hobbying.